What if Earth was as big as the Sun? Let's have a fun question. What if the Earth was as big as the Sun? Well, we would have more land and resources for a growing population. If the Earth were that big, but would have the same mass, gravity would be much weaker, so we could jump very high and even sail. We could fly. Ladies and gentlemen, welcome to the Epictainment Show. This is What If the Earth Was as Big as the Sun? In this video, we are going to forecast this epic scenario, so grab your snacks and watch this show. Also, if you're new to this channel, make sure to subscribe to this channel and press the bell icon to get notified every time we upload a new video. If you enjoy this video, don't forget to give it a like. Now, let's begin. Well, if the Earth becomes as big as the Sun, following three major differences would be there. Number 1. Earth's gravitational pull will be so strong that it would attract celestial bodies in the same way as Jupiter, which acts as a protective shield for the Earth. Number 2. Since the Earth would be much slower in space-time, it would be a millionth of a second as heavy objects are being pulled more slowly through time. A quick look at a black hole will give you a good idea. Number 3. It is possible that the Earth will have more moons than it does now, and will most likely be uninhabitable by advanced creatures such as humans. Now let's have a deep understanding of the possible hypothetical scenarios. There are 3 scenarios. Number 1. The Earth is the size of the Sun, but the mass of the Earth. Well, if that happens, we would end up with a very light, floating Earth. We would be 1,000 times denser than air, and essentially turn into a cloud of dust. The gravity of the clouds may have brought it back at some point, but given the effects of gravity from other planets, it's very likely that we will end up like this. Number 2, the Earth is the size of the Sun, with the mass of the Sun. It basically replaces the Earth with the Sun. We will turn the solar system into a binary star system, and we will probably destroy all planets in the solar system. Enraged by this sudden change in the system's center of mass, the orbits of the planets would become unstable, and most of them would pass close to the new star, dying a terrible death from tidal forces or from crashing into the new star itself. The inner planets and most of the gas giants will suffer this fate. Distant objects are unlikely to notice a change in the center of mass of the solar system, only an increase in mass and a closer orbit to a new star system. And in the end, 4.5 billion kilometers away, a lonely and impersonal blue planet will cry again because it has no friends, and probably never will, given that most of the material from the protoplanetary disks that make up the planet is completely absent, since they merged with the planets billions of years ago. Planets could not have been formed. Number 3. The Earth is the size of the Sun with the density of the Earth. This is where things get interesting. At this density, Earth would be a star with 3.9 solar masses. A star becomes nothing, stays as a big planet. The short-term effects will be similar to scenario 2, but the long-term effects will be very interesting. Since the Earth's sun is 4 times larger and more massive than the Sun, it will die in less time in general. More massive stars burn faster with their fuel. It will either expand depending on the mass of its core, or it will explode into a Type 2 supernova, or it will explode its outer layers into a planetary nebula. If it were to be a supernova, the Sun would be extinguished because it was so close to the explosion, and we would have a ball 20 kilometers in diameter, a neutron star, a star made of degenerating matter of neutrons. The thing is very dense and rotates very fast. It is best to stay away from it. If it were to become a planetary nebula, the dust in the nebula would likely be collected by the Sun and added significantly to its mass, but not enough to change the way it died. Behind is a slightly larger Sun and a white dwarf, a star made of electronically degenerated material. As the Sun goes through its life, the Sun moves. It will rise to become a red giant after the hydrogen in its fusion core is exhausted. As this giant expands, matter, which is mainly hydrogen, flows on the white dwarf and accumulates high pressure and temperature. As matter accumulates on the surface of a white dwarf, it reaches a temperature and pressure high enough to initiate a new fusion reaction. In short, white dwarfs become stars again. However, if the mass of a white dwarf accumulates after crossing the Chandrasekhar boundary, it will explode into a Type 1a supernova explosion. No one gave up, and what was once part of a blooming Milky Way was nothing more than a cloud of dust. Earth will collapse on its own and turn into a neutron star when it is as big as the Sun. The Earth as a neutron star would be 10 kilometers in diameter. Which scenario is more interesting for you and why? Let us know in the comment section. If you like this video, do not forget to give a big thumbs up and subscribe to the Epictainment Show. See you in the next video. Thanks for watching.